Okay, I'm going to do problem number 16. It's even. The answer is not in the book, and I think this is a great example on how to do hypothesis testing for two proportionals. So the first thing you must do is that you need to define your P1 and P2. And so notice how each one includes the word proportion. So this is the proportion of low-weight births born to mothers who were exposed to soot and ash, and P2 are the proportion of those who weren't. All right, and so now we're going to go into our hypothesis testing. So I'm going to go to the second screen. And so remember, our HO is always that the two are equal to each other. And then HA is that 1 is greater than 2. Because remember that the soot and ash, I think, is more likelihood than the non. So that is greater than. All right, so let's do our conditions. Oh, you know what I forgot to do? I forgot to say that we're doing a 2-prop Z test. This time on the quiz, I'm going to take off if you don't do that. Okay, so let's hope that the word here is random. And I do not see the word random here at all. So we have to write this. I'm going to write it down, okay? Okay, so I'm going to assume that the low-weight births were chosen randomly. Okay, next I'm going to do 10% condition. And you have to write out 10% condition. And I'm just going to add up my ends. So I have, 182 plus 2300 are less than 10% of all births. Remember, births. The hits are the low-weight ones. Okay, and then I'm going to do independent groups. And I'm going to say the two groups do not influence each other. And then I'm going to do success, failure. All right, and the first thing I'm going to do are the 9-11, the soot and ash ones. I guess I have to be careful on how I say that. And so what do we have is going to be 0.08 times 182. And that barely makes it, that's 14.56. And then the failures are going to be 0.992 times 182. And so 182 minus 5. And I get 167.44. And both of these are greater than 10. Okay? Non-ash and soot. So this is 0.04 times 2300. This gives me 92 is greater than 10, and this is 0.96. Two 208 is greater than 10. So all my conditions have been met. So conditions for a 2-prop Z. Oop, I don't want to say that. For a normal distribution. Have been met. Okay. Okay, so now I'm going to go do my z-score math. So I'm going to get z is equal to, and so it's going to be 0.08 minus 0.04 minus 0. You do have to say minus 0. And then all I want you to do is do pool. Okay, I'll find out what that is when I go do my calculator. So the probability. All right, so I just put this all into the calculator, and I got a z-score of 2.71. So the probability that P1 is greater than P2 is equal to the probability that z is greater than 2.71 is equal to 0.0033. That's my p-value. All right, and so I'm going to look here, and it doesn't give an alpha. It doesn't give an alpha. All right, so when they do not give an alpha, you're either going to ask yourself, is my p-value small or is it big? Okay, so let's look at this number here, 0.0033. Typically, the lowest alpha we would use is 0.01, and the biggest alpha we would use is 0.10. So do you agree with me that this number is less than? So we will reject HO since my p-value of 0.0033 is small. I can't compare it to alpha, so I'm going to say that it is small. All right, so I'm going to say there is evidence to suggest that the proportion of low-weight babies is higher. Now, this is actual data, and it's kind of sad, isn't it? All right, so if you concluded there is an a difference, this is B, estimate the difference with a confidence interval and interpret it in your context. So now let's go do a confidence interval. So it's going to be 0.08 minus 0.04. Now I don't have to do conditions because I already did them. All right. Now I need a confidence interval. I need an alpha. I don't see an alpha in here. All right. Since I don't see an alpha in here, I'm going to assume it's 95%. So I'm going to do 1.96. So I have 0.08, 0.92 over 182 plus 0.04. Yes. So I have 0.04 times 0.96 over 2300. Okay, that's all underneath the square root. Okay? All right, so now I'm going to go to my graphing calculator, so let me pause. Okay, so I got 0.0016 to 0.0832. Now, if there was a difference, if there was not a difference, if there's no difference, do you agree with me that P1 would equal to P2? If I put them on the same side of the equal sign, I get 0. All right, so let's look in the confidence interval. Is 0 in the confidence interval? And the answer is no. So that means there is a difference. Because 0 is not in the confidence interval, there is no difference. If 0 was in the confidence interval, then there is a difference. Okay, so they asked me to interpret it. So we are 95% confident that the proportion of low weight births from 9/11 is 0.16% to 8.31% more than other births. Other low weight births. All right, there's a lot here, okay? So if you need any help with this, come in for tutoring.